Hello and welcome back to Mech Zone. In the previous lecture, I have already told you that today we shall be starting with the chapter on flywheel. So we were in the last turn we were discussing about the turning moment diagram, and in the turning moment diagram we saw that alpha was actually coming out to be a function of time. So this variable alpha or variable acceleration is actually producing jerks, and these jerks are even more dangerous as compared to just fluctuations of or vibrations. So these are actually controlled by means of a device called as a flywheel, and a flywheel is actually directly mounted on engine. Actually today I am having sore throat, so I may not sound very good to you, but still I promise that I'll be finishing each and every thing related to SSC, JEE and GATE before before the first week of December. So flywheel is actually directly mounted on the engine, and hence crankshaft and flywheel are treated as one link. The crankshaft and flywheel are treated as one link. Okay, they are generally treated as one link. So what flywheel is actually doing, flywheel is actually trying to maintain T as constant so that the value of alpha can also be maintained constant and the jerks in a system can be significantly reduced. Okay, so now let me start with the chapter of flywheel. This is a very important chapter because इससे भी एक या दो नंबर के तो क्वेश्चन हर साल almost guaranteed ही रहते हैं. So the first topic that we have to start today is the turning moment diagram for single cylinder double acting steam engine. Turning moment diagram, in short it is TMD, for single cylinder double acting steam engine. Okay. Now it was developed by Sir James Watt. This engine was developed by Sir James Watt, and we will see that both strokes are positive. Both strokes are positive, and the function of flywheel is same in all engines. The function of flywheel is same in all engines, that is to reduce the fluctuations or jerks. So if I draw the turning moment diagram, that is the T versus the theta diagram, so I will find okay, so this line actually is called as the T mean line, T mean or mean torque line. So the portion which is lying above this T mean line is designated as positive, and the portion which is lying below this T mean line, it is actually said to be negative. Now what do we understand by positive and negative? Positive simply means that the energy in this region would be more than the required, and hence it will be stored in the flywheel. And negative means the energy will be deficient, and hence the stored energy in the flywheel will be released. Okay, so this mean torque is also called as the resisting torque. Okay, the mean torque is also called as the resisting torque, or it is also called as the load torque. Okay, so the portions which are lying above, so we are mainly going to focus on these regions. Okay, and this is the positive region. This is also a negative region. So actually the mean torque is defined as work done of the cycle upon 2 pi, because here what we are getting is this is 0, this is pi, and this is corresponding to 2 pi. So W cycle divided by the total angle of the cycle, that is 2 pi, will give us the mean torque, and area of the T theta diagram in any cycle will give us the W cycle. The area of the T theta diagram will give us the W cycle. Okay, now even after the installation of the flywheel को लगाने के बाद भी हम देख रहे हैं कि कुछ पॉइंट्स पर जो हमारी स्पीड है मिनिमम भी है और कुछ पॉइंट्स पर हमारी स्पीड मैक्सिमम है. फॉर एग्जांपल दिस इज n minimum 1 and here it becomes n maximum 1. Here again it becomes n minimum 2 and this becomes n maximum 2. Okay, let us say this point is A, this point B, this point C, and this point is D. Okay, now if we talk about the minimum ranges of the speed, we have n1, n2 and so on, such that we are getting a minimum speed. And if we consider the maximum section, then also we are getting n1 maximum or n2 maximum and so on, such that from this we will obtain the n max. So we have seen that even after the installation of the flywheel, we are having the fluctuations of the speed. So one important point is W cycle will be generally evaluated by means of integration. Now what would be the fluctuation of speed? Fluctuation would be n max minus n minimum. So we see that the fluctuations are still left even after the installation of a flywheel. So we now define a parameter which is known as the coefficient of fluctuation of speed. It is equals to n max minus n min upon n, where this n actually is called as the average speed, that is n max plus n min upon 2. Okay, and this CS is called as the coefficient of fluctuation of speed for the flywheel. For example, we have been given CS is equals to 2%. It simply means the value is 0.02. But for example, we have been given CS is equals to plus minus 2%. So since it is plus minus 2, we will multiply this value by 2. Hence it becomes 4% and this is written as 0.04. Okay, so we have to remember this. Now we will define another important parameter, that is CE, and CE is equals to E max minus E min upon W cycle, such that this CE is called as the coefficient of fluctuation of energy. Coefficient of fluctuation of energy. Okay, for the flywheel. So area which is lying above the mean torque line will be positive and the area which is lying below the mean torque line, it is negative. So we are actually observing the areas which are lying either above or below the mean torque line, which is actually representing the fluctuation of energy. Okay, that is delta E. So one note point which is very important here is sum of all the positive areas, that is sum of all the areas above the mean torque line, would be equal to sum of all the negative areas or sum of all the areas below the mean torque line. मतलब mean torque line के ऊपर जितने भी areas हैं वो सब positive है, उनका summation that would be equal to the summation of all the areas lying below the mean torque line. So if we discuss what is the basic function of a flywheel, then basic function of a flywheel. तो बिफोर स्टार्टिंग दिस आई वुड लाइक टू रिक्वेस्ट यू ऑल कि अगर आपने अभी तक हमारा चैनल सब्सक्राइब नहीं किया है तो हमारे चैनल को सब्सक्राइब कर लीजिए. हमारे चैनल के बारे में अपने फ्रेंड्स और कलीग्स को भी बताइए सो दैट दे आर ऑल्सो बेनिफिटेड, बिकॉज एवरीथिंग इज अवेलेबल एब्सोल्युटली फ्री ऑफ कॉस्ट ऑन आवर चैनल, बी इट द स्टडी मटेरियल और द क्वालिटी वीडियो लेक्चर्स. यू कैन ईजिली व्यू आवर लेक्चर्स और बार बार हमारे लेक्चर्स देखिए और अपने नोट्स प्रिपेयर कीजिए एंड ट्राई टू सॉल्व द प्रॉब्लम्स विच हैव बीन आस्क्ड इन द प्रीवियस एग्जामिनेशंस and try to solve at least 25 years of problem with minimum 3 times revision. Okay, so if we talk about the plus sign, then plus sign simply means the flywheel is storing energy and negative sign simply means it is releasing energy. Now when it will be storing energy, when the energy would be in excess, and when it will be releasing energy, when the energy is deficient. Okay, when there is deficiency of energy. So thus a system to work at very high speeds must have low inertia of the flywheel. Why? Because we have kinetic energy is equals to half I omega square. Thus a system which is working at very high speeds must have low inertia of the flywheel. Okay, that means the I value should be less. For example, racing bikes, if we talk about racing bikes, then whereas in case of punching and press operations very low, रेसिंग बाइक्स में तो हमारा ओमेगा बहुत हाई हो जाता है, तो उसके करस्पॉन्डिंग हमारा आई की वैल्यू काफी कम होनी चाहिए. whereas if we talk about punching and press operations, ऐसे केसेस में हमारा जो ओमेगा होता है वो काफी कम हो जाता है, तो उसके करस्पॉन्डिंग हमें वैल्यू ऑफ आई काफी ज्यादा रखनी पड़ती है. ओके, नाउ विल डिस्कस अबाउट द टर्निंग मोमेंट डायग्राम फॉर सिंगल सिलेंडर 4 स्ट्रोक आईसी इंजन. सिंगल सिलेंडर 4 स्ट्रोक आईसी इंजन. ओके, नाउ आई विल ड्रॉ द टी थीटा डायग्राम, and this is the T mean line, that is the mean torque or the load torque line, and I will divide this into say 4 equal parts for my convenience. Okay, so this angle would be 0, this is pi, this is 2 pi, this is 3 pi, and this is 4 pi. So the diagram would look somehow like this. I will extend these lines first. Okay, so this is actually the shape of the turning moment diagram, such that this area which is lying above the mean torque line is the positive corresponding area, and all the area which is lying below the mean torque line is actually representing the negative area. Okay, this is all negative area. Okay, now we see that there are some small portions which are positive also. This portion is actually positive, and here we have this portion also as positive. So here also T mean can be written as W cycle upon 4 pi. Now we will divide T mean by 4 pi because the total cycle angle is actually equal to 4 pi. Okay, now we will start with the fundamental equations of flywheel. So fundamental equations of the flywheel, we will say M is actually the mass of flywheel, and let us say K is the radius of gyration. Some people say it gyration, but the correct pronunciation is gyration, such that for the ring we have radius of gyration is equals to the radius of the ring, and I is equals to mk square, such that it is equals to mr square. And if we talk about the disk, now what is the difference between a ring and a disk? In case of the ring, most of the mass is concentrated at the periphery, whereas in the case of the disk, we have seen that for like compact disk or a DVD, it represents the disk, whereas the mass is not entirely concentrated on the outer periphery. Here K is equals to R by root 2, such that I is equals to mk square, and it becomes mr square by 2. So please do remember these two cases because they are very commonly used and they are being widely asked in problems also. Now we will find the maximum fluctuation of energy. Maximum fluctuation of energy, that is delta E max is equals to E max minus E minimum. and this is equals to half I omega max square minus half I omega min square, because E is equals to half I omega square. So we will take half I common and we have omega max square minus omega min square. Now we will apply the formula of a square minus b square, and such that we will obtain 1 by 2 I omega max plus omega min into omega max minus omega min. Okay, now what we will do is we will multiply and divide by 2, and we will multiply and divide by omega also. So what we will obtain, 1 by 2 I omega max plus omega min upon 2 multiplied by 2, okay, and omega max minus omega min whole upon, okay, omega and multiplied by omega. So हमने क्या किया, 2 से multiply कर दिया, 2 से divide कर दिया, omega से ही multiply कर दिया, omega से ही divide कर दिया. Okay, now we can observe that this quantity simply becomes omega, or we can call it as omega average, and this quantity simply becomes coefficient of fluctuation of speed. Okay, so we can simply write it, and this 2 and 2 gets cancelled out, so this actually becomes delta E max is actually I omega square CS. Please remember this formula because it is very important, and this entire procedure is very important in itself because numericals are directly asked from this formula. Now we see, for example, that we have been given a T theta diagram such that this is the T mean torque line. Okay, so the portion which is lying above, it is positive, and these are actually negative or deficient energy regions. This point is A, this is B, this is C, and this is again A. So what we will do is we will simply apply for this region, we will apply delta E max is equals to I omega square CS for this रीजन. मतलब ये इकलौता रीजन ऐसा है जो टोटल एनर्जी को पॉजिटिव करने पर बड़ा आसानी से कर दे रहा है, क्योंकि ये और ये इसका इफेक्ट नहीं है, डायरेक्टली इतने ही रीजन पे ये जितनी भी एनर्जी होगी दैट वुड बी करस्पॉन्डिंग टू डेल्टा ई मैक्स, एंड वी विल सिंपली राइट दिस एनर्जी इज इक्वल्स टू आई ओमेगा स्क्वायर सी एस. ओके, नाउ वी टेक अनदर एग्जांपल व्हिच इज सिमिलर टू दिस. ओके, सो say we have like this is positive because that this is T mean line, and this is also positive, and this region is negative. So we will definitely apply delta E max is equals to I omega square CS for this region. Okay, and we will solve the numerical. And please note one point, that coefficient of fluctuation of speed, that is CS, is actually not dependent upon omega average, or it is directly proportional to omega average की power 0. ये independent होता है. Okay, now for I will solve some numericals relating to flywheel. Okay, and this problem actually has been asked in IES, and this is a very standard problem, such that T has been given as 10,000 plus 2000 sine 2 theta minus 1800 cos 2 theta. Okay, where theta is actually has been given as the crank angle from the top dead center to the bottom dead center. Coefficient of fluctuation of speed plus minus 0.25%. So we will multiply it by 2, and hence it becomes 5%, and 5% can be written as 0.05. and n has been given as 250 rpm. Length of the crank is given as 80 centimeter and radius of the crank has been given as 20 centimeter. Okay, so first we have to find out the power of the engine. First we need to find out the power. The second point, we have to find out the moment of inertia of wheel, that is the flywheel. And third, we have to find out the alpha at theta is equals to 45 degree. So this is the question which has been asked, and it's a very basic question. It is not at all tough. So with this we come to the end of this lecture. I will be solving this question in the next lecture. So do subscribe to our channel and also tell others about our channel so that they are also benefited absolutely free of cost. So thank you so much, and we shall be doing this problem in the next lecture.